Welcome back to my channel Impart Math Knowledge. This video is about partial differential equation. Here we are going to discuss about Lagrange's method of multiplier. Check my previous video for Lagrange's method of grouping. The Lagrange's linear equation is of the form PP plus QQ is equal to R. The auxiliary equation is dx by p is equal to dy by q is equal to dz by r. With the auxiliary equation, we have to find the general solution for this equation. The general solution is pi of c1 comma c2 is equal to 0. For finding the constants, either we go with a grouping or multiplier method. In this problem, I'll explain multiplier method. The problem is mz minus ny p plus nx minus lzq is equal to ly minus mx. This is of the form pp plus qq is equal to r. Here p is nothing but mz minus ny, q nx minus lz, r ly minus mx. The auxiliary equation is dx by p is equal to dy by q is equal to dz by r. So that you can write dx by mz minus ny, dy by nx minus lz, dz by ly minus mx. If you take two ratios, the grouping method is not possible because the variables are different. Here z and y is there, here x and z is there, and here y and x is there. So the grouping method is not possible for this problem. So we go with multiplier method. Here we have some constants L, M, N and the variables X, Y, Z. According to the variables and constants, you decide the multiplier. For finding C1, take the multipliers X, Y, Z and then add X, D, Z by X, D, Z by MZ minus NY X. Second ratio y dy by y nx minus lz z dz by z ly minus mx. Now we can write this as x dz. Operate x inside. X dz. The denominator is x mz minus nxy. Here y dy, the denominator is nxy minus zyl. The last ratio is z dz by z y l minus zx m. Now adding this, x dz, y dy plus z dz. The denominator is xzm nxy plus nxy minus zyl plus zyl minus zxm. Now this can be written as x dz, y dy, z dz. The denominator xzm and xzm getting cancelled, nxy and nxy getting cancelled, zyl and zyl getting cancelled. So the denominator is 0. X dx, integral of y dy plus integral of z dz is equal to 0. Integral of x is x square by 2. Integral of y dy is y square by 2. Integral of z dz is z square by 2. In term C1. So C1 is x square plus y square plus z square by 2. Finding the second constant, we take the multipliers L, M, N. L in the first ratio, there is L dx by L mz minus ny Taking the multipliers, L in the first ratio, M in the second ratio, and N in the third ratio. Adding this, that is L dx plus M dy plus N dz by L mz minus ny plus M nx minus lz plus N ly minus mx. Adding the numerator and the denominator. Now L dx plus M dy plus N dz. The denominator is Lmz lny plus mnx minus mlz plus nly minus mnx. Cancelling the like terms, lny, mnx, mnx, lmz, lmz. So the denominator is L dx plus M dy plus N dz by 0. The denominator is 0. We can write this as L dx plus M dy plus N dz is equal to 0. Integrating this, integral of L dx plus M dy plus N dz is equal to 0. That is, L is a constant term. So L, integral of dx is x. M is a constant term. Integral of dy is y. N is a constant term. Integral of dz is z. And the right hand side constant is C2. The general solution for this equation is pi of C1 comma C2 is equal to 0. That is pi of x square plus y square plus z square by 2 comma lx plus my plus nz is equal to 0. The Lagrange's linear equations is of the form pp plus qq is equal to 0. The auxiliary equation is dx by p is equal to dy by q is equal to dz by r. For finding C1 and C2, either you go with a grouping or multiplier method. Hope you all understand. Thank you for watching.